Hello, this is video number 3 in a series dealing with PlayCanvas Blender shaders. This particular topic is going to be what's called material capture, and we touched on that in the first part. Actually, the first part was 2 videos. One is to install Visual Studio, and the other was showing how you could add extra additional what they call matcaps to Blender interface. And then the second video was an introduction to how to create something or download something from Blender Swap, a model like the Space Shuttle, and then import the materials into PlayCanvas. So this one, now we're going back to some of the code. It's not necessary that you understand C++, although I will step really briefly into it. You can skip over that if you want, because what we're interested in is the net result, which is to have a fragment shader and a vertex shader that we can use to replace the material in PlayCanvas and be able to display these different things similar. Okay, so I'm going to just show you an example of this in Blender. So the interesting thing about material capture is it's a very cheap way of giving sort of an impressive look on a 3D model, particularly if the model is like a bust of a face or something, where you've got a lot of different contours. So the general idea is it takes a bitmap, an image of a sphere, and the sphere having all the shading and so forth, map that to this kind of object based on what's called normals, and the normals are essentially surface normals. Just mean that if this is made up of a lot of little triangles, which we can see. Let's see if we can find that. If we go into here and put the wireframe, you see all these different little triangles that make up the surface. And there is, at each vertex, or even you can think of it at each of the surface of the triangles, there's a vector that kind of points perpendicular to the surface, and so that kind of gives you the direction. If it's pointing directly at you, then it's essentially it's kind of, that plane is kind of parallel to the plane of the viewing plane. If it's if that vector is pointing sort of to the right, then it's sort of the side part of that. So the basic idea then is just to take a sampling of that so let's just show you rather than just endlessly talking here. So let's go into the wireframe, turn that off. If you bring up this panel, if it's not up automatically, use the N key. This panel here has a bunch of display options, and if you're in this particular mode, solid mode, I think that's the only time where this MatCap shows up. You go to multi-texture shading and you turn this on, and you get this really kind of cool effect. Again, in my previous videos we talked a little bit about this, and this particular one I added, if you remember from my previous videos, I added 5 of these to the interface, to the Blender interface, which is kind of cool. I actually changed some C code, did some magic. Well, in this particular case we're not going to worry about that, but we would like to know, how is it, what is the logic that's used to get this nice shader effect? So that was my task. Now I'm going to show you what the goal is. So I'm going to show you the final product in PlayCanvas, and then I'm going to build this whole thing from scratch, just pulling in the logic. And also, this particular project is available. It's public, so you can actually go into the PlayCanvas source code, and there's a demo on that too, and I'll probably keep that up for a period of time. I only have about 1 gigabyte right now. I do have an organizational thing which has a subscription to an organizational one, but I'm using that for my organization. And so my private one only has 1 gigabyte, so there's a kind of a limit on how many demos I can put up there. But this one's pretty cool. Okay, so that being said, let's move Blender out of the way, and I'll show you this is what the goal is. This is PlayCanvas. This is running under PlayCanvas. And I created this app, brought in this, I exported out this bust as an FBX. And then now you can see if I click on these different things here. Let me hit the space bar here to keep this. So the cool thing about this thing, if you look at it, if you look at any one of these, it's literally taking this bitmap and then doing this really cool transformation. Now what's amazing about it is it's only a few lines of code. It's just unbelievably simple, the fragment code that makes this possible. And yet you get this really cool effect with steel and yeah, that's chrome effect. So the problem comes in, so essentially you can almost see, if you go back here, you can see that this is an image of a room that's reflected back onto the surface. So you're kind of doing all this work here to create a really nice bitmap of a sphere with all the reflection, and then just kind of mapping it on. But you know, if you were in a game, it wouldn't be that realistic, because if you move the camera behind it, this is only a hemisphere. It's only one half of the sculpture. So, but who cares? This is used a lot. For example, I can turn this into clay. This is used a lot when you're trying to sculpture face and kind of see, oh yeah, I've got these cheekbones and so forth. So it's very, very useful without, you know, being very expensive performance-wise. And it's just kind of fun. I just kind of really think that some of these pretty interesting effects just by changing these bitmaps. Even this black one is pretty good. Okay, so this is our goal. Now, how did I find the code? So what I'm going to do is, very briefly, and don't get scared, I'm going to set a breakpoint. I'm going to bring up an environment, a Blender environment, and I'll probably pause this because it takes a little time for it to come up. And then I'm going to show you where I found the code for the fragment and vertex shader. If you're not familiar with those terms, you might want to look those up. I assume that you have some basic knowledge of what a fragment and a vertex shader is, and there's lots of documentation on that. It's part of the GLSL language. So as I bring up Visual Studio, I've got I think a July version solution of Blender. I'm going to bring this up, and conveniently I've already got the line of code that I want to set a breakpoint in. And the reason I want to do that is it didn't take too long to figure this out, but you look for the word fragment in vertex, and here's the fragment code in the vertex code. If I set a breakpoint here while I turn that MatCap on, I will literally find the code that's needed to do that. Now, you could probably find this online, but it was kind of fun to find it here. So we'll do that. So I'm going to launch. This takes a few seconds, so I may pause. And I do this by going to debug and then start debugging. It's going to bring up an instance of Blender, and then I'll bring in that sculpture and then turn on the MatCap. Okay, it took a few minutes to come in here. So basically I'm launching Blender in this debugger, and what I want to do is I want to get to a point. It doesn't really matter what model I bring in. Bring this pterodactyl. So I will switch to solid mode, and then down in here I'll turn this MatCap. So what I'm going to do is I'm going to click on that, but I want to set a breakpoint first. Right here. Yeah, so this there is no geometry shader. in this example here, so I can set a breakpoint clearly here. And now I will click on MatCap, and now you can see this arrow here. You hit this piece of this code. This turns out to be GPU underscore codegen.c at around 1677. And what you can do is you just hover over and then hit the magnifying glass, and it pops up in magically. This is literally the shader code. There's two parts. There's a vertex shader and there's a fragment shader. Most of this I've already got from my other projects. I've got sort of a standard vertex shader that I use. So this is super complicated. I'll use a simplified version of that. The really important one is going to be this fragment shader, because this is actually when the colors are defined. And this is the amazing code. You come into here, this color for every little pixel on a triangle comes through this, and this is the function we need. Oh my gosh. So now what do? I don't know where that function is. So it's material preview matcap. If I could find where this function is, that will give me the solution to the fragment shader. Well, it turns out in this same module, let me take off this breakpoint and then do a continue. And if I go to let's see if I can remember the number. Yeah. So around 272. Again, a lot of this is guessing. I used to do for a living. I used to do a lot of system level programming and looking at other people's code. So I'm pretty good at reverse engineering code. So anyways, and they've got some nice naming conventions here. It's this GLSL material library. Sounds like this would be a good candidate. So I'm going to turn this MatCap on again. Let's see if I can trigger this. I have to do something substantially different. Get that. So the key to triggering this code, so I come out here and I come here and say cycles render, it pops into this code here. So if I open this up, so look under this, textual visual, okay, so we got, looks like a library of all kinds of little shader functions. So probably that material, that matcap function is in here. So what I'm going to do is do a select all and then put it into word processor or notepad, and then search for and there it is, this material preview matcap. So this is the magic code. I've sort of ignored this part up here, but essentially this part is what I'm going to pull out, and you'll see that this corresponds to the code that I use in the PlayCanvas to get that effect. Essentially is doing the steps. I have a blog in minds.com somewhere. Right here. So if you go to minds.com/paperclip, actually, it's called, my name here is paperclick, you'll get to some of my blog entries. If I do paper click, and you go to this is not published yet, but it will be part of my published items. So in here right now it's just unlisted, so I'll go to my blogs, and this will be available basically in a tweet link. So in any event, this is sort of documenting this video, and this video will be actually included here. So this will be the place to start with. So in here, the steps for this particular technique boil down to convert the surface normal to a view space, convert the normal from -1 to 1 to 0, 1 space, sample the texture at this calculated UV coordinate, and then make sure that texture is actually a render of a sphere. So that's essentially what this code boils down to. So this is enough of the debugger right now. Just wanted to show you how I actually figured this out. Now what's going to be really cool in the future is that any type of rendering that you're doing in Cycles Render, you can literally pull the code from that library out. So if you're doing some really fancy stuff, you can literally pull that in and pretty much duplicate that in PlayCanvas as well. But that's going to be more of an another video, more advanced video. So anyways, that's the technique I'm using here. So let's turn this guy off. So we've done what we needed here, and then I just kill this application in the debugger by just turning this offline here, and then I can dismiss. Okay, so now we'll go back and we're going to build a PlayCanvas from scratch, and we're going to duplicate that application. So we're going to duplicate what I've got here. So I'm going to start and create a new project. I'm going to default with this Model Viewer Starter Kit because it has a nice camera to start off with, and do a create. And we'll go into the editor. One of my previous videos went into a little bit more detail. I'm going a little fast in here, assuming that you know the basics of PlayCanvas. Come into here. I'm going to get rid of the model, default model. I don't need this cube. And in the cube map itself, I don't need this helipad. So I'm just going to have a black background. And then we go over to settings, rendering, and I can just kind of drag that in. This may need to be refreshed. It still thinks it's got the helipad background. Oh, yeah, there's one other item. Oops, don't want to do explore. And go back to settings. I think you have to set this MIP to 1. Now we got the black background, so we should have a empty. So this is going to be a Beethoven sculpture. So we're going to be importing in an FBX file, which is a model. So I'm going to create a folder called Beethoven, my favorite of all composers. And now I will go to, and the FBX file should be available. I'll somehow make it available in the blog. So we just drag that Beethoven FBX into here. It doesn't have any materials. We'll just drag this JSON part into here, and now we got the sculpture. And so now I've got some notes. which kind of describe what goes on to this particular object. So we're going to have some code, and we're not going to be worried about the materials because we're going to replace that. And so I'm in the scripts. I am going to bring in one of the first of my files, the script files, and it's going to be called shader, custom shader JS. And just drag it into here. Now if you click on this, it'll get into the code editor. Okay, so this has some custom attributes that we can drag and drop. So this is the way we're going to, this code here sets up the replacement of the current material with your own shader logic, and this is kind of the format that's going to be used. You can, like I said, the project's available. You can go into the code and look at it. I won't dwell too much on how this works, other than it's here to do that. Now what we'll need to do is we need the vertex shader code and the fragment shader code. So I'm going to drag those guys in. There's the GLSL. Well, that. Now if you go back, you can see what I did was I extract out a very simple, very standard way of doing a vertex shader. It does some transformations. We're going to be passing in. This is actually GLSL code now, very much like C code. Now the uniforms are sort of like constants that are passed in from the outside, and PlayCanvas actually has some special variables here, or essentially variables or constants that we pass in, which include the matrix model, view projection, and normal. I'm not going to go into all the details. That requires, there's many videos on how this works with OpenGL, but you need this to do the transformation, to get to be able to pass this information to the fragment shader. It's going to take the surface normal and then do a conversion so that it can be digested by the fragment shader, and it's also going to pass in this matrix times the point, which is the vertex itself, and pass that into the fragment shader. Also, we're going to be passing in this texture coordinate as well. But let's see if that's going to be used. That's not going to be used in this particular case because we're actually creating our own, basically our own UV coordinates using this technique. Oh, I take that back. I take that back. Okay, scratch the previous. Yeah, the UV coordinates is not going to be used. However, we're going to pass in that bitmap, which corresponds to the diffuse map. And that's done through here. So we've got 3 attributes. So now I'm going to assign this to the surface itself. So the way we do that, click on here and say add component. And we're going to add a script. Add the script, and we'll look at the custom shader. And now this has these attributes that you saw in the code, vertex, fragment, and diffuse map are here. All we have to do is just drag in. There's the fragment shader, vertex shader, and then the diffuse map. Okay, we don't have that yet, so we're going to create another directory, which we'll call MatCap textures. And okay, so where did I get these? It turns out if you look at my previous videos, I went into a discussion of where those reside in the Blender code, and I just very quickly will show where those are. When I created my developer environment, you can go into, I think this is one of the older ones I had. You go into Blender. So this, like I say, this has been detailed in a previous video. You go into Release, and then Data Files, and MatCaps, and here is all the JPEGs for these. So I literally just drag all of these guys in, and plus I've added a few more, and just drag those into the PlayCanvas. So these are all available in Blender. So I'll go back to my other notes here, and so I'll open this up, and here's, I've got just a file where all of these are. So I'll just kind of grab a bunch of these. Let's see here. So I had stored a bunch of these plus a bunch of other interesting ones out here, and I'll just drag some of those over. So it'll be basically the 25 plus the 5 extra ones that I did. These come in, we should see them. And I'll add a few more. They got off the web. Okay, so now go back to Beethoven, and we'll drag one of these in here. So we'll just drag this guy into here. So now if we just run the app, this magic should work. So yes, indeed, we've got now this particular. However, there's something a little bit weird about this. It's because I'm moving the camera rather than the object itself. So I've got another piece of code that comes from one of the tutorials, the PlayCanvas tutorials, to actually rotate an object. I think it had a gem, and I'm using that. I'll bring that in, and then we'll see it different. So that one I called rotate object. I'll put that in the scripts. And I'm going to attach that and turn off the camera. So I'll go into here and say add script rotate object, have that enabled, and then turn off the orbit camera, and then also the mouse input, because that other one actually supports the mouse. And we get an error. And the error is because there's some attributes that we are supposed to pass into rotate object, and this is going to be the camera entity. So if I click on that and then go here and then do a refresh, we have one other problem. And that problem had to do with the fact I had to turn off all of these guys. So under the camera, these kind of work together. So I turned off the orbit camera, touch input, and so forth. The only problem here now is the camera. It's a little bit too close. So we need to adjust the camera. And the camera, I think I've specified a good position for the camera in my notes, which is these values here. And let's see, no rotation. And then what you can do is you can kind of lock this camera and then just move the bus back so it's in a good position. And now we've got a nice position for this. Okay, we're almost there, except what we wanted to do is we wanted to create some GUI here so that when we clicked on it, we could dynamically change this. But what you're seeing now is I'm literally, if you go into, you'll notice this is completely white, and there really is not any material to speak of on here. We're just doing all this material programmatically through the shader. If you look at, we go back to our scripts, these are the essential pieces here that we pass in. And this part here, this is the code that you need to actually create the shader. You want to be able to pass in these magic values. So we see V vertex, V normal, and so forth. This is the texture coordinate. This is the surface normal, and vertex. That corresponds to what you see in here as an attribute coming in. Now, PlayCanvas uses a slightly older version of GLSL than Blender does. And so I think the newest versions of GLSL just use ins and outs. But in the older version, they use attributes and varying. So when you're actually passing to the next part of the pipeline, so this gets executed first, then it passes this information. The varying is kind of like out, and the attributes are kind of like in. So the only thing we need to do now is to have some sort of GUI so that we can easily just click on these different and do it in a way that's really easy to just dynamically add. So I've got a script that does this quite easily. Doing GUI using CSS and HTML almost requires a video in itself, or several videos. I'm going to just really quickly, at the top level here, I'm going to just add a script. And under the scripts here, I'm going to create a folder and call it GUI, just so that we can keep that straight. I'm reaching towards the end of my limits on video time. Open this up and we'll drag in 3 scripts. This is going to have some attributes associated with it. We're going to attach it to the root. And so let's do this. Now sometimes there are some refresh issues. It didn't recognize when I was trying to add that demo script. So one way around that is just to add a new script with the same name. So I'll just call it demo. And then when I bring this up in the editor and I take the demo code from a notepad, just copy it in, and then this thing satisfies its quirks. So I'll go into here. So now we've got this demo code that should be at the root level. We click on this parse to be able to see all the attributes that's defined. So like in my previous video on the gravity and gravitational field, it showed how these things here are attributes that can be passed in through the GUI. So you define these. It's going to be an HTML, CSS, and a texture, and that corresponds to these. So since these are special types, I can just drag these in. And now the matcaps is actually an array of texture maps. So we can, let's say, let's just add 5. You add 5, it adds 5 slots here, and we go to the matcap textures, matcap textures, and we can just drag in, let's see, we can start with, yeah, we can start with this guy. And you can add these after the fact, so if you want to add another one, just change it, and it has a new slot. Okay, so that should work now. And voila, we've got. Now the code here is a little bit in the compressed side. In order to make this so that I'm literally generating, if you look at the HTML, it's just a placeholder. And if you look at the CSS, it's just got some basic classes here. And then I actually generate more code based on how many of those textures that you put in. So that's kind of the magic there. You'll just have to kind of look through the code, see how I did it. It's too complicated to really explain in this video, which I have to come to a close soon. But the general idea is that you can put these nice overlays on your 3D viewer. So that pretty much covers it. Building this kind of really nice MatCap viewer and how I got there. So in subsequent videos, I will go into even more detail on maybe some complex shaders that you can create using Blender, using the cycles render. And it turns out that each of those nodes that you create, there's a function that goes, or more than one function that's associated with them. And they're all contained in that library that we looked at. So you can define something that you really like, and then some of those things may not come over by just a straight export to FBX, but you can then take over the fragment and vertex shaders, and then actually begin to do some animated textures as well. So anyways, this should be it. And like I said, if we, what I said is basically there's a blog associated with it, and that blog is you can get to it through minds.com, pay-per-click, and once I publish it, it should be available in my blogs. So anyways, if you haven't seen this one, this is kind of a fun one too, this gravitational field. And I'm going to have more and more. There's lots of really cool things you can do. What I want to do in the future is have a video shows you how to download this and run this off your own server, so you can be sort of independent of PlayCanvas server. And you'll also be able to add things like you have total control, so you can actually have Angular JS, and you can use other tools as well. Any libraries that JavaScript has, like jQuery, and get really fancy. You could have split screens where, say the left side's a 3D viewer and the right side could be pure HTML. I can show how to do that. So in the future, I'll have more videos as I discover more. So happy computing for now.